considering for the condensation. So condensation is the basic process which is reverse to the boiling. So boiling is essential to convert liquid into vapor stage. Here condensation is required to convert the vapors into liquid. Wherever we want to convert the vapors into liquid, there is a methodology, and with accuracy we have to go forward for the condensation. So here, what is condensation? Condensation sets in whenever a saturation vapor comes in contact with a surface whose temperature is lower than the saturation temperature. So one thing we have to remember, that the temperature of the surface should be lower than the saturation temperature of the vapor. Means in simple meaning, vapor temperature should be higher and surface temperature should be as low as possible. So when the temperature difference is higher and higher, condensation is very easy. How the condensation will take place? Vapors will attack on the surface. When the vapors are attacking on the surface, vapors have got high temperature and the surface is having low temperature. And because of the temperature difference, vapor lose the heat to the surface of the object. And because of that, the vapors are converted into liquid. That liquid will attack on the, or it will stay on the surface, and after, due to gravity, because the liquid is heavier, it will drop down and we will collecting at the bottom. So condensation is very much essential, because we have to convert vapor into liquid in chemical factories or sugarcane factories or in thermal power plant. Even after the expansion of the turbine, we are going for the condensation, and to get the, again the liquid is recycled in the thermal power plant. So all these necessary. So fundamentally what we have to what is required is, the vapors should be at high if it is high temperature, surface should be at very low temperature. That is essential. As the classification of academics, there are two type of condensation. One is film wise condensation, another is a drop wise condensation. First is the film condensation. In the film condensation, there is one arrangement. There is a plate and the vapors are attacking on the plate. Vapors is kept at low temperature as already said, and vapors are at high temperature, that is saturation temperature, and they are attacking on the plate continuously. And when the plate is exposed to the vapor, vapors are setting on the plate and the vapor will transfer the heat to the plate, and because of that heat transfer, because of the temperature difference between plate and the vapors, the vapors will lose the heat, and that vapors will be converted into liquid, and as the liquid is heavier, then this drop down. Here in the film wise condensation, film is created. One layer of the vapors will attack on the plate, second layer will attack, third layer will attack, fourth layer will attack, the fifth layer will attack. Continuously the vapors are attacking on the plate. Because of that, layer by layer the liquid will generate. So one layer, initially the plate will be facing the vapor, second set of vapor will face the already generated liquid, third set of vapor will face the second layer of liquid. Likewise it will go forward. Because of that, after some time the condensation will be, the efficiency of the condensation will come down, because the vapors are not directly contacting the surface, but instead they are contacting the already condensed layer. So therefore, initially the condensation is very fast, and after some time the condensation is lower and lower, the rate will be lower and lower. So if the condensate tends to wet the surface and thereby forms a liquid, that is called as film wise condensation. What is film wise condensation? A layer of liquid will form on the surface, and that layer will drop down because of the gravity. This is the gravity. So because of the gravity, the liquid will drop down. So that is called as film wise condensation. Usually in all engineering applications, we are going for the film wise condensation. Second is the drop wise condensation. Drop wise condensation is only on the very fresh, very dry surface, and small crevices or small pits are there, then it is very better. And when it is completely dry, then when the vapors are attacking on the plate, then it will condense very fastly, because the vapors are directly in contact with the surface, and the surface at the various points, that droplet will be created. The very good example of this drop-wise condensation is, early in the morning if you go in the garden, on the leaves of the plant, there are some droplets spreaded on the leaf. So that is called as drop-wise condensation. Means for condensation, compulsorily we have to provide a surface. If we do not provide a surface, condensation cannot take place. So therefore, the leaves will provide the condensation surface, and very fresh, dry and very clean surface, and the curvature on the particular leaf will provide the droplet formation to be very easy. Here in this droplet condensation, plate is provided, very dry is there, and here and there we can see the pits are there. On a particular pits we can go for condensation, that is vapors will be condensed and drops are formed, that is called as condensate drops. The vapor condenses into small liquid droplets of various sizes which fall down the surface in random fashion. The droplet will fall down in a random fashion, but that is only for one time, because when the surface will become wet, then second set of vapor will not have the dry contact but wet contact, because already it is wetted by the earlier layer of the liquid. So second layer, third layer, fourth layer, fifth layer, they will find the wetted only. Therefore, initially only we can go for dropwise condensation. Later is converted into film-wise condensation. Means academically, though the film-wise condensation and dropwise condensation are different, we have to see that film-wise condensation is practically more applicable. So where we can use, in the thermal power plant, condenser is there. The steam coming out of the turbine will be condensing in the condenser. The organic liquid or organic vapor is in the any chemical industry will be converted into liquid. In sugarcane industry or any other industry, when the vapors are to be converted into liquid, we are going for condensation process. And here in the given problem, various surfaces will be given. Vertical plate will be given, horizontal plate will be given, pipes will be given, vertical pipes, horizontal place of pipes are there, various orientation and various size and various shapes we are being. So you have to refer the heat transfer data book, so that we will get the equation. Only the task remaining is you have to collect the data from the various sources in the data book and just substitute it and get the answer. So very easy, but one thing you have to see that you have to get acquainted with the data book. Data book, if you use efficiently in this particular condensation chapter or also in the boiling chapter, nothing is there. So here all the data you have to collect it from the different sources, and then you have to substitute it, and whenever interpolation is needed, that should be done. Interpolation formula already I have given in the earlier classes, that x minus x1 divided by y minus y1 is equal to x2 minus x1 divided by y2 minus 1. That equation has to be used for interpolation and get all the values and just substitute it, will have the answer. So this is the condensation process. But one thing you have to remember that you have to just go through the heat transfer data book. In condensation, what are the various type of condensation equations are available in different situations, that you have to utilize it, and in the engineering manner and according to given numerical problem, you have to solve the particular problem, and we have to collect the data. So that is called as condensation process. In future, we will see how we can calculate the condensation process exactly as in an engineering method.